Class CS687 Capstone, Spring Quarter 2023. Video number 1 of 6 total on the benefits of a proposed method of quantifying complexity induction for the purpose of generating feedback loop parameters for assistance when pursuing optimized heuristic solutions to 2D traveling salesperson type problems using a nested triangles derived convex hulls solver adhering to both shortest delta distance and inner to outer layer consumption criteria by AWilkinson, candidate Master's Science in Computer Science, School of Technology and Computing, City University of Seattle, advisor Dr. Ali Khamizpour. Agenda. Problem statement. Insufficient research literature exists regarding the benefits of using a complexity induction-based feedback loop as an assist when solving 2D recombinant problems using convex hull inner to outer layer consumption. Motivation: to produce a better algorithm, to augment the applicable research literature, to provide the author an MSCS candidate with means to display propensity for both abstract and critical thinking, to provide a platform on which to improve personal coding skills using Python programming language. Background: a hobbyist Python program scripted for solving 2D dataset TSP traveling salesperson problems with nested triangles as its core engine was constructed. The algorithm at this time used shortest resulting delta distance after merge criteria as selection criteria for down select to arrive at merge decision. Delta distance after merge simply means that the distance AB of line segment AB represents original distance, and distance A to C and C to B represents the new distance. So new distance minus original distance equals delta distance, which when using complexity induction would get multiplied by input parameters. Here we see final solution, 2 separate final solutions for 6 nested triangles plus 2 interiormost points. The solution on the left works off of delta distance criteria. The solution on the right works based off of an angle criteria. The solution on the left represents shortest distance. The algorithm was then used for more complex, non-engineered data set. The data set shown is for 194 cities in Qatar with the convex hull for the data set shown, and my convex hull solution path based on shortest delta distance merge criteria shown. The solution is considered invalid because of a crossover and also does not represent community-acknowledged shortest traverse path. However, results are considered encouraging and establish the solver as a capable instrument for this investigation, namely use of complexity induction as a method for obtaining improved solutions using convex hulls. An updated, improved version of the code was sought.